All right, hi guys. In this video, we're going to be talking about section 6.1, 2, and 3, about ratios and similar polygons. So throughout this video, please take notes as needed. And if you ever need to stop or if you need more time, then just pause the video. Okay, so I'll need you to be vocal about that if you need to pause the video. All right, so reminders about ratios. If I have a ratio of A to B, that means that if A and B are two quantities that are measured in the same units, then the ratio of A to B is given by this fraction, A over B. You can write it as A to B in words, as a fraction, A over B, and then as a colon, A to B. Okay, a proportion is simply an equation that equates the two ratios. Okay, so if I have two different ratios, let's say I have A over B, sorry, my computer messed up, A over B, and I equal that to C over D, that is what we call a proportion. Okay, so reminder about proportions. Properties of proportions. We have the cross product property, and that means if I multiply along the diagonals, then I can set those diagonals equal to each other. That's usually how we solve proportions. Okay, so I would have A times D equal to B times C. We also have the reciprocal property. So if I have A over B equals C over D, then I can flip those fractions. So I can flip these around to be B over A equal to D over C. And if you think about it, it's because their cross products are really the same. This is going to still be A times D is equal to B times C. Okay? Some terminology I need you to know. If we have a proportion, then the numbers on this main diagonal here are what we call the mean. And then the other numbers on the other diagonal are called the extremes. All right, so in section 6.2, we have some properties of proportions that we can use. So we'll be doing some of these to help simplify some proportions. We just talked about the reciprocal property, so you don't need to write that first one again. The next one, though, if you interchange the means of a proportion, then you form another true proportion. So remember, the means are on this diagonal. So notice what they did is they switched them around. So basically, it means it doesn't matter if you go A over B equals C over D, or whether you go A over C equals B over D. So you can either go vertically or horizontally. They mean the same thing. All right, and then in number 4 here, this last property, I don't know if you're familiar with this one as much. Basically, if we have a proportion and we add the value of each ratio's denominator to the numerator. So for example, in this first ratio, B is the denominator, so we're going to be doing A plus B in the numerator. Okay, and then the same thing with the other one. D is the denominator, so I'm going to do C plus D in the numerator over there. That maintains that proportion. And really, if you think about it, if we have things like this, I can separate these fractions into A over B plus B over B. Okay, that equals C over D plus D over D. Well, what happens with B over B? B over B cancels. That's just 1. Okay, this cancels, so it's like they're canceling. Okay, so that's why it doesn't impact anything. It's like we're adding 1 to both sides. Okay, so those are our rules. And now let's take a look. If you look at your homework packet, make sure that you all have your homework packets. If you didn't get those yet, then pause the video and make sure you have them now. So if we look at our homework packet, I'm going to look at number 3. So I have 1, 2, 3, and 4 up here, but I want to look specifically at number 3. So if we do this, it's asking us to fill in the blank. What goes in these question marks? So what happened here? What did they do? They have this original proportion, and what did they do to get 19 over 12? Well, they really did 7 plus 12 over 12, didn't they? So if they did that, then we have to do the same thing on the other side with the other ratio. So we have to do 31 plus y over y. So 19 over 12 is going to be equal to 31 plus y over y. So I wanted to do one like that with you so you understand what the directions are asking you to do when you do your homework. At this time, let's also look at number 12 on your homework packet. So in this one we have, here, let me move this. We have the area of an isosceles triangle is 36 square inches. The ratio of the length of the triangle's base to its height is 2 to 1. They want to know what is the perimeter. So if they're talking about an isosceles triangle, let's draw an isosceles triangle. Okay. And then they're talking about area and the base and the height. So I want to draw in, here's our base, right? And then the height, remember, goes perpendicular to the base. This is the height. Okay? So if they say it's in a proportion or a ratio of 2 to 1, the base to height is 2 to 1. So that means whatever the height is, the base is twice as big. Now, we don't know exactly what that height is. So we're going to say, okay, whatever this is, we're going to call this x, just to simplify the variables. Then the base is going to be twice as big, 2x. Okay, so whenever they give you a ratio like that, you can just do 2x to 1x. So that means the same thing, right? X is just a variable, a multiplier of your ratio. So let's use the knowledge that we do know. We know that the area is 36 square inches, and we know area of a triangle is 1/2 base times height. So let's fill in the gaps. So area is 36, and we have 1/2. My base is 2x, and my height is x. So if we simplify that out, the 1/2 times the 2 cancels, and then I have x times x. So I have 36 equals x squared. And then take the square root of both sides. And so I'm going to get x equals plus or minus 6. Now, if we think about this, though, I can't have -6 because my height is supposed to be just plain old x. So I really don't want plus or minus 6. I just want positive 6. All right, so we know what x is. We're trying to find the perimeter. Okay, so we know the base then. We know the base is going to be 2 times 6, which is 12. Okay, so this whole length is 12. But we need to find those legs of the isosceles triangle. So let's think about this for a minute. If it's an isosceles triangle, I'm going to redraw this over here. And I have the height, which is perpendicular. Then remember what we said. If this is perpendicular, then I have that middle line there. I have two triangles that are congruent by hypotenuse leg theorem. Okay, so since both of those are congruent, then we know that this base down here is going to be split in half by that height. Okay, so the reason I'm pointing that out to you is because if we know this is 2x, then each of these is going to be x and x. And then we also know this is x. So what do I have here? Well, we know what x is. X is 6. So this is 6 and this is 6. So we can do Pythagorean theorem to find that hypotenuse. So if we do that, we're going to get 36 plus 36 equals 72. So if I take the square root of that, that gives me 6 root 2. Okay? So going back to my original diagram, I know each of these is 6 root 2. Okay, so now we're ready to do perimeter. Perimeter is going to be 6 root 2 plus 6 root 2 plus 12. So remember when we combine these, we just add those 6's together. So that's going to be 12 root 2 plus 12. You can also do a decimal if you wanted to, and that would be about 28.97. So depending on what the directions asked, if they wanted a decimal or not. Okay, I also want to look at number 13 in your homework packet. Okay, so we're talking about points that lie on a segment, and then they give us some proportions there. So again, let's draw out what we're talking about. So I have WZ is a segment, and then I have points X and Y lie on them. I don't know where they lie, and it doesn't really matter. So I'm just going to label this X and this Y, and I don't know that those are necessarily congruent or equally spaced or anything like that. Okay, so what do I know? I know that WX over XZ is equal to 2/5, and WY over YZ equals 7/8, and XZ is exactly 37.5 meters. So I'm going to plug this into my proportion here. And I'm going to solve for WX. Okay, so if I solve for WX, if I cross multiply and divide, then WX is going to be equal to 15. So if this is 15, okay, that means that the whole thing is going to be in proportion to that. So keep in mind that we know that WX versus XZ is in a ratio of 2 to 5. Okay, so if my WX is 15, then X here is going to be my 7.5. So then if I do that, sorry, this is X is, let me write this, X is 7.5. I'm running out of room. All right, so if I do 7.5 over here, I'm going to have 5 times 7.5, which is 37.5. So that means this whole length from W all the way to Z is going to be 15 plus 37.5, which gives me 52.5. Okay, so why am I doing all that? Well, I really want to know what that whole length is because I'm going to connect it to the Y part now. Okay, so now I'm going to do the Y part. I'm going to do that in green. So WY compared to YZ is in a ratio of 7 to 8. I'm going to use a different variable than X. Okay. I'm going to use Y. So 7Y, 8Y. Okay, so we know that 7Y plus 8Y has to total to be 52.5. So you see how I use the total from here to help me with the total with the Y's. Okay, so I have 15Y equals 52.5. Solve for Y, and I'm going to get 3.5. Now remember, that's just telling me what this variable is. We're trying to figure out what WY is. WY is just the 7Y here. So WY is the same thing as 7 times Y. So that's going to be 7 times 3.5, which is 24.5. So being able to set up your ratios with the X's and Y's and variables is very helpful when you're trying to figure out diagrams. All right, so we've got those. Let's go back to our notes. All right, so if you need to, pause the video, and I want you to try these problems on your own and check it with people in your group. And then when you are finished, you can unpause the video and check your answers. Okay, so we have to tell whether this statement is true. So let's look at to see what they did. So they have m over 7 is equal to n over 11. And then over here, they're doing m over n. And let's see, that should be the same as 7 over 11. And And that's true. That's one of our properties that says we can change the means, switch the means, and it's still the same proportion. So yes, that is true. And on this one down here, what did they do here? So they added the denominator over here. So they have the v plus 5. So what should they be doing over here? Well, they should be doing w plus 9, but they didn't. They used that same denominator over here. So this is false. Okay. So notice that they're not going to be able to cancel on both sides. They're going to have 5/9 over here. Where here, they would have 5/5. So this is false. All right. Hope you got that one right. We're going to move on and talk about this problem. Okay. So we have 3 angles in a triangle, and they have this ratio of 2 to 2 to 5. And I want to make sure we're okay. It's okay to have a ratio with more than just 2 numbers in it. They just keep going with their colons. And they want to know what is the measure of each angle. So just draw a triangle. And again, we don't know exactly what they are, but we just know the ratio. So just put some variables behind it. Let's use x. So 2x, 2x, and 5x. All right, so now what can we do? We can set up an equation. All of these angles add up to be 180. So 2x plus 2x plus 5x equals 180. All of those combine to equal 9x. So x is equal to 20. So that means that these angles right here are each 40 degrees. And then this one right here is 100 degrees if you plug x back in there. Okay, so another example of using that x with your ratio. All right, here we've got a perimeter of isosceles triangle is 56. So guess what we better do? Draw an isosceles triangle. The ratio of LM to MN is 5:4. All right, so it says the base is NM. So L has to be the vertex angle. And then they said the ratio of LM, that's this guy, to MN, that's this guy, is 5:4. So this one is going to be 5x, and this one's going to be 4x. Okay? So keep in mind that because it's isosceles, this is also going to be 5x. And we know the total is going to be 56 because they told us the perimeter is 56. So let's make another equation. 5x plus 5x plus 4x equals our total perimeter of 56. So 14x equals 56, which means x is 4. And then we just plug back in. So if I plug that in, this side is going to be 16, and each of these sides are going to be 20. All right, moving on to similar polygons. All right, so if I have similar polygons, and that could be any figure, okay, 3 or more sides. All right, here's our definition, so make sure you definitely write this down. Similar polygons, 2 polygons such that the corresponding angles are congruent and the corresponding sides are proportional. What do I mean by proportional? It means that if I make proportions out of those sides, then all of them will be equal. All right, so if you need to pause to do that, then write that down. Pause it and write it down. I'm going to move on. So if I look at these figures up here, it's telling me those are similar. And so here's how we write a similarity statement. It's very similar to how we do a congruence statement. So I need to make sure I match up the letters in the correct order. So I'm going A to B to C to D. Okay, so A, B, C, D is going to be similar. Notice that I'm using this little squiggle to mean similar. And I'm going to start with H, and then I'm going in the same direction. H, I, J, K. All right, so here's our similarity statement. All right, all of those, the order of the letters matters. So let's look at this. They give us a similarity statement, which we just talked about. And then let's talk about the statement of proportionality. This is when we are discussing the individual sides, like I was saying. all the sides have to be proportional. So if I do AB, those are the first two letters, that's going to correspond to the side HI. So AB over HI, that proportion or that ratio should be equal to, if I scoot this over, so now I'm going to do BC and then IJ. And then I'm going to do CD and JK. And then finally, I'm going to do the first and last. So I'm going to do A and D, and then H and K. Okay, so that is a statement of proportionality. So statements of proportionality have proportions in them, whereas a similarity statement has this similar squiggle symbol right there. Okay, so some terminology I need you to use. All right, so let's look at an example. All right, so we're going to use this diagram to help us complete this similarity statement. So like I said, we got to match up the correct letters. So M is the single arc, then O is the double, and N is the no arc. So we're going to do the same order, GHI. And then I can write my statement of proportionality. So MN, that's first and last, goes with GI. ON goes with HI. And then MO goes with GH. So if I match up those sides, 16 is going to match up with 12. And then X is going to match up with the 10. And then we can cross multiply and divide. And that would give us X is equal to 13.3 repeating, or 13 1/3. All right, and if I do the same thing for this other proportion, so 12, remember, goes with 16. And then now we're going to do 8. So 8 goes with Y. So that's how we fill in that proportion. So again, if I cross multiply and solve, 80 plus 48 would be 128. Divide by 12. So I'm getting 10.6 repeating, or 10 2/3. Okay, so that's how we can set those up. Now let's talk about scale factor. Scale factor is simply the ratio of the corresponding sides. So I have to know two sides in order to know the scale factor. So let's look at this example. We're constructing a rectangular play area. We have a playground that is also a rectangular, and its length is 25 meters and its width is 15 meters. So I'm going to, let's draw this. We've got a playground. Its length is 25 and its width is 15. All right, now we're going to have a play area. It's similar in shape, but it's only going to be 10 meters in length. Okay, and I don't know how wide it's going to be, so I'll put an X there. All right, so they want us to find the scale factor of the new play area to the playground. So we're going to match up the 10 with the other length with 25. So if I do 10 over 25, and I need to reduce that, so reduce that by 5, so that'll give me 2/5. 2/5 is my scale factor. All right, and then it wants us to find the perimeter of the playground and the play area. So I need to find my X. So I'm going to take my proportion here. 10 over 25 is going to be equal to X over 15. So if I cross multiply, Now you get x equals 6. All right, remember that's not what they're asking though for, so we're going to do the perimeter of the play area. So the play area is 10 by 6, so then that'll be another 10 by 6. So that's going to be 20 plus 12. So 32, ooh, I forgot my units. What are my units? 32 meters for the area, play area. And then for my playground, that's going to be 25 by 15. So I'm going to have 50 plus 30, which is 80 meters. Okay. So now that we've done a few of those, let's look at this one. We've got polygons that they're telling us they're similar. If they are, write a similarity statement and find the scale factor. So we need to match up our letters. So I'm going to start with F and then go to J, H, G. So F, J, H, G is similar to Z, W, X, Y. Okay. Oh, you know what? They didn't tell us they're similar. They're asking us if they're similar. So that would be our similarity statement if we knew for sure they were similar. So what do we need to know? Well, we need to know all of the angles are congruent, which they are, and then we need to know all of the sides are proportional. So I need to know that 16 over 20 reduces to the same thing as 12 over 15, and 24 over 30, and 20 over 25. So if we reduce all of those, 16 over 20 reduces to 4/5. This also reduces to 4/5. This is going to be, 4/5. And then this is also 4/5. So yes, they all equal 4/5. So we know that they're similar, and 4/5 then is our scale factor. I'm going to put SF for scale factor. Okay, moving on. The two triangles are similar, so we have to find the missing sides. Alrighty. So they told us now that these are similar. So what matches up with what? So 15 matches up with 10, and then X is going to match up with 6. So let's find X over 6 is equal to 15 over 10. So we got 10X is equal to, let's see, 60 plus 30 is 90. So I'm getting X is equal to 9. So that's one of our sides. And now we need to do the Y plus 3 one. So I'm going to do Y plus 3 and 8. So I'm going to keep that 15 over 10. I'm going to do Y plus 3 over 8 is equal to 15 over 10. So I'm going to have 10 times Y plus 3 is equal to, let's see, 80 plus 40, it will be 120. Now I could distribute that 10. Rather than distributing, I'm just going to divide both sides by that 10. It'll make my numbers smaller. So I'm going to get Y plus 3 equals 12, and then Y is going to be equal to 9 as well. But remember, that's not the side length. 9 is going to be plugged in, so this side length is 12. Okay. Alrighty then. Let's do this one. This one is kind of the same idea, but we're going to have a different looking proportion. So we're given that these are similar, and we're going to solve for X and Y. So if I look at what's going to be similar to each other, I'm going to have 2X matches up with the X, and then 2 matches up with this, X minus 1. So let's make a proportion. 2 over X minus 1 is equal to 2X over X. All right, so if I cross multiply, 2X on that diagonal, and then on this diagonal I have to distribute. So I'm going to have a 2X squared minus 2X. So I did 2X times X minus 1. All right, now I'm going to solve this, and this is a quadratic. Do you see how it has both an x squared and an x. This is what we were talking about. So combine your like terms, get everything on one side equal to 0. All right, and then we can either do quadratic formula or we can factor. I'm going to factor. It's a lot easier. Now this doesn't have a third term, so we're not doing that. We're looking for common factors. So what can I divide each of those by? I can divide each of those by 2x, so that goes in front of my parenthesis, and then that leaves me with x minus 2. So remember, I'm going to set each factor equal to 0. And then I'm just going to solve. So I have x equals 0 and x equals 2. Now keep in mind, x is actually a side in my polygon, so I can't have a side be a length of 0. So this answer does not make sense. We need to get rid of that. So x is equal to 2. All right, and then we would do the same thing with y. Okay, so I would have y plus 8 is equal to y, and then 6 is not equal, they're matching up. So y plus 8 over y is equal to 6 over y minus 2. All right, so again, we're cross multiplying. On this one I get 6y. Over here I have to FOIL, so remember I'm doing y plus 8 times y minus 2. So I'm going to get y squared minus 2y plus 8y minus 16. And now we got to get everything on one side equal to 0. All right, so I'm going to subtract that 6y. That leaves me with, let's see, these two combine to give me 6y. And then what happens is I have a positive 6y, and then I'm going to subtract that 6y, so there are no more y's. And then I just have minus 16. So you can either factor this, or since I only have a y squared, then I don't need to get everything on one side. I can just add that 16 over and then square root both sides. So I'd have y is equal to plus or minus 4, but again, I don't want to have a negative side, so I really don't want the negative. I really just want the positive 4. Okay, so be aware that some of your problems could have quadratics in there. And then this one is also very similar. So I'm not going to do another one like that. Let's look at a word problem. Let's do one more looking at a word problem. So we have a scale drawing. Is a drawing that is the same shape as the object it represents, and the scale is a ratio of how that describes the dimensions in the drawing and how they're related to the actual dimensions. You can write that down if you need to. Like I said, if you need to pause and do that, but I'm going to go ahead with the example. All right, so we have a 3D model of the Willis Tower in Chicago. The actual height of the building, including its TV antenna on top, is 1703 feet. The model that we're using is 29.4 inches tall, and that also includes our antenna, which is 4.4 inches on top. So just to give you an idea, we've got this actual building, and it has this antenna on top, and then we've got our little model with our little antenna on top. So this part right here is 4.4 inches, and then this whole thing from top to bottom is 29.4. The actual building, they're telling us the whole included thing is 1703 feet. So we're trying to figure out, well, how much is the actual antenna? Okay, so we're just going to set up a proportion. All right, so I'm going to put x, the actual antenna, over the model antenna, 4.4. And that's going to be equal to 1703 over the 29.4. Those are the total heights with actual and then the model one. So I'm going to have 29.4x is equal to 7493.2. Divide by that, and then we get x is equal to 254.87. Now, since we're in actual height, then we're talking about feet here. Now that they're asking how many times as tall as your model is, times as tall your model is your actual building. So now we're just comparing the actual heights. So keep in mind that 1703 is in feet, and if I'm going to compare it to my height of my model, I have to change that into feet. So the actual height is 1703 feet, which is the same as, well, how many inches would that be? We have to multiply by 12, don't we? So that's going to be 20,436 inches. All right, and then our model is 29.4 inches. So if I want to get our ratio, how many times as big, then we're just dividing. This divided by the model size. And that comes out to be 695.1. So it's about, so roughly 695 times as tall. All right, guys, so that's our proportions and similarity notes for these 3 sections. And now what you can do is work on your homework packet.